Okay, guys, this is Dr. Kell. We're doing 6.2 day 2 notes on similar figures. Okay, so again, this chapter we are looking at similar figures, which uses the symbol like that, not congruent. Okay, so it is not the same thing as congruent figures, which is what we did last chapter. Okay, so we're going to be able to identify similar figures. We are going to be able to solve problems involving similar figures. This is probably the biggest part of this today's unit. And we're going to look at finding the scale factor. Okay, finding sides with similar figures. If two figures are similar, then these sides are proportional. Okay, not congruent. So what we're going to do is we're going to use the similarity statement to write a proportion with the sides. Okay, we're going to use values from the diagram, our known values from the diagram, and we're going to have to put a variable in there somewhere, more than likely. Okay, sometimes we have to create that variable, sometimes it's part of the problem, and we're going to solve that. And like we did a couple lessons ago, we're going to cross multiply. Okay. We'll see plenty of examples in a second. Okay, so finding angles with similar figures. Okay, if two figures are similar, think back to what we did in 6.2 day 1. If two figures are similar, the corresponding angles are congruent. Okay, so here is the deal, is you don't get to just guess and assume which sides are corresponding, so which angles are corresponding. So you have to use these similarity statements to figure out which angles are congruent. Sometimes you have to write an equation to determine which sides are proportional, okay? And sometimes we have to solve for the angle measure using algebra. Okay, so we'll have plenty of examples for this, but the big deal here is that you must use your similarity statement to decide which angles are corresponding. Okay, I got a text. Okay, so let's look at problems 1 through 4. Given each pair of similar figures, we're going to find the requested side. Okay. So we're going to find DE. Where is DE? DE is right here. I like to put a variable in when I don't know that side. I'm going to go ahead and give it an X. Okay? So I know that CBA is similar to EFD. Okay? Okay, so I need to set up a proportion in order to solve for DE for my variable. Okay? So let's look at what I know here. Well, I know that the side lengths are proportional. I know that, for example, CB over EF, that ratio is going to be the same thing as like BA over FD, okay? And then that ratio is in turn, come on, handwriting, don't fail me. Okay, that ratio is the same as ED over CA. Okay, I don't know all of these sides. For example, I don't know the side length. Okay, I don't have that information. So this ratio is not going to be useful to me. Okay, I don't want to use that one. It's not useful to me. What I do know is I know BA, okay, BA and FD. Okay, that one's going to be useful to me, okay? So I am going to say 5 over 6, and that is going to be equal to ED, which I determined is my X, over its corresponding part, which is CA, in this case is 10. Okay, that leaves me with a ratio that I can solve. I used that proportionality there. So I'm going to go ahead and cross multiply here. Okay, this gives me that 50 is equal to 6x. And I'm going to go ahead and divide both sides by 6. 50 divided by 6, we could leave it as a fraction, or it's that x is 8.3. Okay, either way is fine. All right, let's look at another one. Y'all always pause if you're like, what in tarnation? Just go ahead and pause the video and look and figure out what you could do there. Okay. Okay, we are going to find ML. Okay, ML if IJK is similar to LMK. Okay, so I'm kind of looking at this figure and I don't want to write more ratios than I have to. So let's look at what I know. Again, I'm going to put in an X for ML. Doesn't matter what you put in there. It's just a variable so that I have something to work towards. Okay. So I can see that MK, I know MK, and it's proportional to IJ. Or excuse me, to JK, and I know JK. So I know that I'm going to set it up that way, okay? I'm going to do this setting it up in letters first and then plug in the values, but in reality, you might want to skip that step, okay? So I'm going to say MK over JK. That ratio is the same as, I have to go back to the one I started with. I started with MK, so I have to go back to ML over JI. Okay, there is my proportionality. Okay, so now I'm going to plug in my values. Okay, MK is 18 over JK is 6, and that is equal to ML. Well, that was my unknown over JI, which is 10. All right, I could solve that. Hey, if I can reduce, I always want to, simplify first. It just makes the arithmetic easier. 6 goes into itself 1 time, 6 goes into 18 3 times, okay? And now I'm going to go ahead and cross multiply, and this gives me that 30 is equal to x. Okay, if you didn't reduce first, you would have gotten the same answer. It just would have been a little bit, yeah, you got the same answer. Tomato, tomato. Okay, so I want you guys to go ahead and give a go on problems 3 and 4. These are the most important problem types in this unit. In all honesty, these are going to come back to haunt you if you don't kind of get a grip on them. So might as well just get a grip on it now. Pause the video, try it on your own, see what you can do. Okay, so pause the video and go through this, make sure you understand what I did. So I set up my proportions and then I cross multiplied and solved. Okay, I like to reduce before if I can. No rule that says you have to do that. To me, it just is my, how I like to do it. Okay, so here I got for number 3, I got that x is 6, and for number 4, I got x is 8.4. Okay, this side length and that side length. Okay. Oh no, go away. All right, so let's look at 5 through 7. Okay, given that JMLK is similar to ADCB, we want to find the measure of angle M. Okay, the measure of angle M. Okay, well, listen up. I know that when figures are similar, their corresponding angles are congruent. Okay, so I'm going to look over here, and I know that angle M is congruent to angle D. Okay, I'm going to look at this figure, and I'm going to see what can I do there. There's M, there's D. Hey, they told me what D is. So the measure of angle M is 70 degrees. Okay, 70 degrees. Okay, now we want to find the measure of angle C. Well, I know here that the measure of angle C is congruent to the equal to the measure of angle L. So angle C is congruent to angle L. Okay, so here's C. Where's L? Oh, L is right there. L has a right angle symbol in it. So I know that the measure of angle C is 90 degrees. All right. Okay, go away. Okay, find the length of JM. JM is right here. I want to find the length of it. Okay, so I'm going to go ahead and put an X right there because it's the easiest way for me. I'm going to erase all my little arrows here, and I'm going to look up here at my similarity statement in order to set up my proportions. Okay, so starting, I know that JM, I'm going to write it in letters first. JM is proportional to AD. I'm not even looking at the figure. I'm not trying to like look at the figure and figure anything out based on the diagram. I'm looking literally at this similarity statement. Okay? Okay. I'm now going to look over at the figure and see that I actually know LM. So I want to use that one because I don't want to use a side length. Like I wouldn't use JK because I don't have information there. Okay, so I'm going to use maybe LM. Hopefully that one works out for me. Okay, LM is proportional to CD. Do I know CD? I do. Okay, so that gives me enough information to set up my ratio that I can solve. Okay, JM, which is my X, over AD, which is 28, is equal to LM, which is 15, over CD, which is 20. Okay, now I have something set up that I can solve. Again, I want to reduce if I can. 5 goes into 15 3 times, 5 goes into 20 4 times, and I am going to cross multiply and solve. I still have to do 28 times 3. I don't know. If you're my student, you know I can't do that in my head. Okay, that is 84. 4x is equal to 84. And 84 divided by 4, I think that's going to work out nicely. I get x is equal to 21. All right. Again, you guys, this is the most important problem set of this unit so far. This is maybe the hardest part, but also the most useful for where we're going with the rest of our semester. I would like for you to seriously pause, try 8 through 10 on your own, please. Okay? Okay, so for number 10, 9 through 10, the first thing to notice is that angle D is congruent to angle B right here, and B is 32 degrees, so X is 32 degrees. Okay, to find Y is angle C. Well, angle C is congruent to angle F. They didn't tell me what angle F is, but if I remember from last chapter, I know the triangle sum theorem that all 3 angles inside the triangle sum to 180 degrees. So I could figure out angle F at 64 degrees, and that means that Y is 64 degrees. Lastly, they wanted me to find side length Z. So I'm going to go ahead and set up a proportion. I set up the proportion that AD over EB is equal to DF over BC. I'm going to cross multiply and solve, and I got that side length is 6.25. Okay. So let's go ahead and look at these last 2 word problems. Oh my God, word problems. They are not any harder, just don't panic, okay? A man who is 6 feet tall casts a shadow. So here's my 6 foot tall man. They didn't tell me how tall he is on the figure. Maybe I'll just put that there. He's 6 feet tall. He casts a shadow that is 8 feet long. At the same time, a tree's shadow is 22 feet long. Assuming the triangles are similar, find the height of the tree. So this is my X. That's what I'm trying to find, is the height of that tree. This is a ratio. These are proportional. They're similar figures. I know that X over 6, that's its corresponding part, is the same thing. I have to start with the one I started with, is 22 over 8. And I can solve that. I'm going to reduce here. 2 goes into there 4 times, 2 goes into there 11 times, and I'm going to cross multiply. Okay, so that gives me 4x is equal to 66. And divide both sides by 4, and x is, I don't know, I'm going to do it in the calculator is 16.5 feet. Okay, that tree is 16.5 feet tall. Cool. Okay, now let's look at the architect's blueprint of a home. That is the weirdest shaped kitchen I've ever seen. Okay, of a home being constructed is a scale drawing with all similar figures to the actual home. That's how scales work, okay? The ratio of drawings on the blueprint to the home being built is 1 inch to 2.1 feet. 1 inch is 2.1 feet. That is your scale factor, okay? The diagram below shows the blueprint of the kitchen. Find the length of the longest wall in the kitchen if each square on the grid represents 1 inch. Okay, to me it looks like this is the longest wall. Okay? Okay, so that length in inches, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inches on the diagram is, I don't know what that length is in the real house. Okay, that's what I'm trying to figure out. I have no idea. Okay, but I also am told that the scale factor, the ratio of the drawing, is that 1 inch in the drawing results in 2.1 feet. 2.1 feet in the real house. Okay, so I'm wondering if this makes sense to you guys, that 1 inch, if I then put feet down here, this is inches, that things are gonna be weird, okay? So 10 inches and then feet. We need to have things in the same units, okay? It doesn't typically work to mix units. I could go on a tangent, actually, maybe I will. Because if you guys know me or ever come into my classroom, I grew up with in the space industry. My dad worked at NASA in Houston, and I grew up like with a lot of like exposure to space industry. So one interesting story is about a satellite that was being sent to orbit Mars, and it spent, you know, billions of dollars, whatever. It traversed for months and months and months, and just right when it went into orbit Mars, it crashed right into the surface. And the reason that it crashed into the surface after however many hundreds of millions of dollars of trying to figure out what went wrong was a unit conversion, is because they were working in kilometers and miles in the same problem. And that was a mistake. Okay, so we digress, but in this example, we need to have the same unit. Okay, so 2.1 feet. Let me write that better. 2.1 feet, I'm just gonna write up here, is how many inches, okay? Well, I'm gonna do a unit conversion. The way that I do this might be a little bit different than how maybe in your chemistry class. I put 2.1 over a placeholder of 1, just because I like to put something down there. And I know that there are 12 inches in 1 foot, okay? That allows the feet to cancel, and I'm left with something in the unit of inches. So I'm going to take my 2.1 times 12, and that gives me that 2.1 feet is 25.2 inches, okay? Okay, so I'm going to come over here, and I'm going to rewrite my ratio, actually. I'm going to go ahead and erase and just start over. Okay, so I know that 10 inches in my diagram, I'm trying to figure out what is that in the real world. That is going to be equal to 1 inch in the diagram is 25.2 inches in the real world. Now I'm going to cross multiply and solve. And I'm going to get x is 252 inches, okay? Maybe we want this in feet. So I'm going to go ahead, if I just divide this by 12, that would give me my answer in feet. Maybe that'll be better. That is 21 feet. Okay, either way, it didn't specify how it wanted the answer, so either way would have worked. Okay, that concludes 6.3 day 2. Again, if you have questions, ask your peer tutor, ask your teacher.